Welcome back to the video lecture of theories of machine. In this video lecture, we are going to be learning what is the kinematic pair and what is the different types of constraint motion and what is the relation between the kinematic pair as well as the type of constraint motions. So in the last class, we got a definition of kinematic link, either rigid body or maybe the resistance body. When they are connected with another links, they must maintain a relative motion between them. Then we can say that is a kinematic link. So here the kinematic pair. What is the kinematic pair? As we know that the pair is nothing but minimum two. Two links we are using. In this case, the two links are the elements of a machine. They are related to machine. When in contact with each other, when they are in contact with each other, are said to be form a pair. Then what happened here? Only the pair will going to be formed, whether it is going to be a contact. When that relative motion between them is completely or successfully constrained, means here a definite direction, the pair is known as kinematic pair. Alright? In this case, when the two links are in contact with each other, then we can say that is the pair of this one. The two. When they have a relative motion that's going to be well defined, then the pair is nothing but a kinematic pair. I hope the definition is going to be that clear. Now, what is a definite? Here we told that completely or successfully constrained motion or definite direction motion of that we have to check it. What is the definition exactly for this one? So here the completely constrained motion. Then completely constrained motion here, when the motion between the pair, right, the motion between the pair is limited to a definite direction, irrespective of the direction of force applied. Is it clear? When we have a two links are connected, then we can say the pair, and the motion is going to be well defined and limited within that range. Then we can say that is going to be a completely constrained irrespective of the force we have applied on that system. Right? That motion, the completely constrained motion is going to be, we need either the reciprocating motion or maybe the circular motion, that output we need it. Right? That motion we define within that limits, then we can say. Then what is the incompletely constrained motion? In this case also we will get the motion. Then what kind of motion we are going to be getting? When the motion between the pair can take place in more than one direction. So what's the definition? When the motion between the pair can take place in more than one direction. In this case what will happen? In this case completely constrained motion, only one completely that means one definite direction motion we are getting. But in this case chances are there either the more than one we are getting, two or three motions are going to be generating, because it depends on the applying the force. Then we can say that is the incompletely constrained motion. In the third one, it is called successfully constrained motion. What is successfully constrained motion here? When the motion between the two elements forming a pair is such that the constrained motion is not completed, but by some other means. It's clear? So what it is saying, when the motion between the two elements, we know that the kinematic pair and they must have a relative motion, but by itself cannot maintain the definite direction of the motion, but by other means, here some other external force we are applying on that system, maybe that will keep the system in a constrained motion. Right? On this basis, I have given 2-3 graphical examples here. What is the completely constrained motion? We know that a definite direction of the motion we will get irrespective of the force we are getting on that member. So then we can see here. So this is going to be the shaft we do have. Alright, this is the shaft and this is the curler and this is the bearing. So in this case what will happen? This member is going to be rotating about its axis of the shaft. But it's not doing any kind of the translatory motion. But rather than it is moving only its own axis of the rotation. Then we can say this is a definitely constrained motion. Then we can say completely constrained motion. But when it comes to the second example here, we have removed the color from this one. Then this is the shaft, and this is the bearing. So then what happened in this case, and it is also need to transmit the power from one point to the other point. So then there is a chances are there, the translatory motion also we will get it. That means the shaft is going to be moving in this direction also. Because there is no constraint we haven't given. Then we can say this is going to be called incompletely constrained motion. In the third one is going to have, this is called the footstep bearing. Then we can say this is the shaft is there, this is the bearing is there. In this case also it is going to be completely, that is incompletely constrained motion. So then what happened here, the shaft is going to be rotating about its own axis, at the same time it is moving in the up and downward direction also. Then what happened, I am applying the force from its top. I am applying the force from its top, then what happened, this is going to be fixed within that bearing, and then it will transmit the power from that one. Then such a motions are going to be called here successfully constrained motion. Then what happened, that motion is not completed, right? This motion is not completed because it has two types of motion. One is going to be translatory motion, second one is the rotary motion. Then by itself cannot make it. But by some other means, we are applying the force at the top of this one, then we are going to be making fix within the bearing, then it will start to rotate about its own axis. That means we will get a definite motion after we are applying the force. That's the things we call successfully constrained motions of the bearing. My dear friends, we have seen the definition of the kinematic wave and the type of the constrained motion, right? Once again, I am going to remind you, the pair is nothing but the contacting of the two machine elements, we can say that is the pair. But this pair is maintained a definite motion. Then constrained motion, we can say that's going to be a kinematic pair. These kinematic pairs, we do have the three types of constrained motions are available. First one is the completely constrained motion. The second one is going to be incompletely constrained motion, and third one is going to be successfully constrained motion. In completely constrained motion, there is a definite one direction of motion is available. In the second one, incomplete constrained motion, there is more than one motion is available within the kinematic pair. Then the third one is successfully constrained motion. In this case, there is an external agent is acting on that motion, so that we are arresting the second direction of the motion, then we are making to one direction of the motion of the system. Then we can say that is the successful. On this basis, we are trying to solve one problem that's going to be the motion of a piston. The motion of a piston, this piston most of the time is available either the steam engine or the IC engines. In the cylinder of a steam engine is an example of, right? There is a piston and the cylinder. These are the two combinations are available. These are the, what kind of form it is a kinematic pair or a symbolic pair. So we know that this is a kinematic pair. The kinematic pair means they must have a proper constrained motion must be generated from within the system. Then we can say. So then what type of motion we are going to be getting? So here I am going to be taking the cylinder and this is going to be the piston. Connecting rod, crank and crankshaft I mentioned here. So then what happened? This piston is going to be making in this upper. This is going to be the cylinder. This is the piston. So then what happened? It is making the move in the up and downward direction, that is reciprocating within the cylinder, right? So then we can see here the first one what he has given, incompletely constrained motion. If you are able to understand what is the incompletely constrained motion, that must have minimum two motions. More than one motion we can say that is incomplete constrained motion. So in this case, how many motions we do have for this piston? Only one definite direction of the force is available. So then what happens? This is going to be the wrong one. And this is the wrong. What is the second one? The successfully constrained motion. In this case, is it successfully constrained motion? Because it has only one definite direction of motion is available, but second motion is not available. That means external force is not required to put the system in a proper direction of motion. So then this is also going to be the wrong answer. So then what is the completely constrained motion? Then we know that only one type of motion is available, up and downward direction. So then this is going to be the right answer. And the D is going to be none of the above. This is completely wrong answer. So then, in this way, we are going to be solve the problem by the theory as well as the objective type questions. I hope you got the clarity regarding what is the kinematic pair, what is the pair, what is the different types of the motions. I hope. Thank you.